This video is for illustrating the advanced NOVA monitoring system. This is the framework of the NOVA monitoring system. As is shown in the picture, the receiving card is connected to the modules with a flat cable. The modules are cascaded together, and the output ports on the modules are connected to the monitoring card. By doing this, we can achieve the flat cable data detection and point detection. Then the monitoring card is connected to the receiving card with a 16-pin flat cable. Therefore, it can send the monitoring data to the receiving card. Finally, the data will be sent to the computer and will show on the software. NOVA monitoring card supports humidity and smoke detection, power supply voltage detection, one-way cabinet door open or closed state detection, four-way fan speed detection, and eight-way switching power supply voltage detection. Please note that the cabinet door open or closed state detection needs to be installed a contact switch on the cabinet door. When the door is closed, the contact switch is closed. When the door is open, the contact switch is open. The fan speed detection needs to be connected to its terminals with a pulse output wire. For power supply voltage detection, it needs all power supplies to be common ground and the ground wire to be connected to the GND terminal on the monitoring card. Then each positive power wire should be connected to power detection terminals on the monitoring card. Now we are going to operate the NOVA LCT software. Open the NOVA LCT software and click the Monitor button. About the sending unit state. This interface uses three colors to show different states. Green means normal, yellow means abnormal DVI signal, and gray means unknown. Move the mouse to the sending unit topology and will show the detail parameters, such as serial port number, sending unit number, the DVI signal state, and the flash rate. As for the receiving card state, this interface uses four colors to show the different states. Green means normal, red means fault, yellow means power supply fault, and gray means unknown. Now the interface here is gray, which means that it's in an invalid state. Click Refresh. Then we'll show the real-time state of every monitoring card. If we want the topology to become larger, we can adjust the scroll bar here. To know the detail parameters of a receiving card, we can move our mouse to the corresponding topology. Then it will show its location on the screen, whether it can work, and its power supply voltage. This interface also counts the total number of the receiving cards, faulty cards, and power supply fault cards. Therefore, users can get the relevant information intuitively. About temperature, the topology in this interface records the temperature of every cabinet and will show different colors according to the different temperature. To know the detail parameters, we can move our mouse to the topology. Below the topology, it counts the lowest temperature value, the highest temperature value, the average temperature value, the number of the cabinets in which temperature is over the average value, and the number of the cabinets in which temperature is alarmed. About the monitoring card state, it's similar to the receiving card state. Move our mouse to the topology and we'll show its location on a screen, whether it can work, and its power supply voltage. This interface also counts the total number of the monitoring cards, the faulty monitoring cards, and the power supply fault cards. And about the humidity, it is similar to the temperature. In the topology, we can see the humidity value, and below the topology, we can see the highest, the lowest, and the average humidity value. The number of the cabinets in which humidity value is over the average, and the number of the cabinets which is humidity alarmed. About the smoke, this interface uses three colors to show different states. Green means no smoke, yellow means smoke alarm, and gray means unknown. Move our mouse to the topology and we can see the smoke state. Below the topology, it counts the number of the cabinets which is smoke alarmed. About the fans, this interface also uses three colors to show different states. Green means normal, yellow means lack of speed alarm, and gray means unknown. Please note that the speed alarm value should be configured by users. Below the topology, it shows the number of all fans and the alarm fans. About the power, please note that the power value alarm should be configured by users. Move our mouse to the topology. D2 parameters like the voltage value will be shown here. Below the topology, we can see the total number of the power supplies and the number of the alarmed power supplies. About the flat cable, this interface uses three colors to show different states. Green means normal, red means fault, and gray means unknown. Move the mouse to the topology. It will show the D2 parameters, the location of the cabinets on a screen, and whether the flat cable can work. It can even show the faulty signal and data group if there exists faults. Below the topology, it counts the total number of the cabinets and the number of the alarmed cabinets. Let's see the test result. The software shows fault, and we can see the fault information here. Socket 3, scan, OE signal, RGB in data group 1 to 4 are obstructed. About the cabinet door, green means closed, yellow means open, and gray means unknown. Move our mouse to the topology, and the D2 parameters is here. Below the topology, we can see the total number of the cabinets and the number of the open cabinets. About the monitor setting, we can select whether to use auto refresh, which means automatically refresh screen monitoring state and the refresh interval. In refresh setting, we can select the needed monitoring state. And in alarm setting, we can configure the alarm when the temperature and the humidity is over a value, and the alarm when the fan speed and the power supply voltage is below a value. Please note that the default temperature is in Celsius, and we can choose Fahrenheit. About email setting, this interface is mainly used for sending email to the relevant personnel when there is an alarm. To configure it, firstly select Enable Email Notification. To send email, we need an account. Then click Modify Sender to fill in the account and password. Then add the wanted person's name and email address. In email information, we can name the screen in order to inform the addressee that where the screen is. In the email log, we can check the information we have sent. About the monitor control, firstly we select Enable Monitor Control. Then click No Control Information. Click to configure. Here we can configure decrease the brightness or open cooling device when the temperature is over a value. We can also configure power off when the temperature is over the limit. Please note that the power off function is supported by the MFN 300, which can control the LED power distribution cabinet. We can also configure power off when there is smoke in the cabinet. After configuration, we can see the detailed control information in its interface. To check the monitor control information, click Control Log here. About the point detection. Back to the main interface of the Nova LCT software. Click Tool, Point Detect. This interface is similar to the receiving card interface. It uses 4 different colors to show different states. Green means normal, red means fault, yellow means not connected to the monitoring card, and gray means unknown. In point detection parameters, here we can configure the parameters. The proper configuration can make the accuracy above to 99%. In screen topological graph, we can select a cabinet to do point detection. Then click Detect Selected. The software will do detection automatically. The topology will show the number of the faulty LEDs. If we want to know the location of them, double-click the topology. Here we can confirm the precise location of the dead point. Now let's see the result. It shows there are 24 LEDs, 8 red LEDs, 16 green LEDs, 0 blue LEDs. Now we're going to see the precise location of the faulty LEDs. Select the faulty cabinet. Click red, green, blue respectively. Then we can see that there are 16 green faulty LEDs, and the cabinet is in the second row, second column. And there are 8 red faulty LEDs, and the cabinet is in the second row, third column. That's all about this video. Thanks for watching.